Cool. So in this group, like a major motivation of ours, and even the businesses that both Logan and I and Dante work with and do work on, a major motivation for us is helping to make IPFS and Filecoin more usable for developers. And so even when we do these events, we're always talking about developer tools to specifically leverage very specific parts of the network. And so, like Dante mentioned, he's going to be walking you through an IPFS light node. So we thought before we get into the next demo, we kind of do a high-level 40,000 foot view of what's this IPFS Filecoin ecosystem and what are the pieces of it? Because even for us, it's so fast-moving, it's so enormous that even for us, sometimes it's hard to keep track of. So I'll be here to kind of walk you through the vision, like what are the values of this community, and then what are the specific solutions that we're working with IPFS and Filecoin. Obviously, with the open web as it is, there's a lot of different components of that, a lot of different pieces, a lot of different technologies. So specifically, we're talking here about like the Protocol Labs ecosystem of IPFS and Filecoin. So just to give you guys an idea, here are some of the biggest projects. And then there's thousands of companies that work in the ecosystem that are building on top. And so it's really an amazing ecosystem of development driven primarily by Protocol Labs, but then in the last 3 to 5 years has exploded with implementations, developer tooling, and all kinds of adoption. So anyway, I'm here to talk about this. We are also lucky enough to have Angelo here with us from Filecoin. He can probably give you even more information than I can. So anyway, I want this conversation to be more of a back and forth. I don't really want to just sit here and talk the whole time, so feel free to interrupt. I'm going to focus on Filecoin and IPFS. There's a lot of other stuff though, so we can get into that if people are interested. I thought a really great way to introduce this would be to go off of a talk that the founder of Protocol Labs did, Juan Bennett. Basically, he did a talk about the vision for the ecosystem, and pretty much this is the summary: is Web3 is about bringing trust to the internet and how we communicate. And so he does a really good job of there's this cool graphic of the iterations of the web as they go, and where we are right now is it's about read, write, and trust. And so that's really the cornerstone of what we're doing here. There's a lot of projects and a lot of components and a lot of pieces to make this a reality. But anyway, that's kind of the overarching summary. And so I would highly recommend, I am not Juan Bennett, and so I would highly recommend scanning that QR code and watching the video because it's incredible. So anyway, just to set the stage a little bit, the last 80 years, computing has completely transformed how humans operate. We do everything online, whether it's work or play, and now we have billions of people who are all connected. That's amazing. All of this technology has given us the opportunity to advance human and artificial intelligent computing. It's also led to an interesting scenario that may not be very good, which is mass surveillance. And so we're sort of teetering on a world where we potentially are entering this kind of Orwellian digital totalitarianism, as Juan Bennett puts it in this talk. And so really, we're at a very critical century for humans and for our species. There's been life on this planet for a very long time, but this century, very specifically, we have a chance to completely ruin everything we've done, or to really build and really improve how humans get things done. So what's the goal of this? What's the mission of this whole ecosystem? Make our communication systems trustable with math, cryptography, and economic guarantees. The way that Protocol Labs talks about what they do is they're very, very much inspired by Bell Labs. And so there's this whole R&D pipeline that you can see, that Bell Labs kind of, pioneered, or they kind of basically sort of made this a thing. And this is the exact same way that Protocol Labs goes about what they do. So Juan Bennett started this in 2014. 9 years later, we've moved into way past development and production and application development, and there's, as I said, thousands of businesses built on top. Some tools are still in R&D, and they're still maybe over here. So the ecosystem is growing, and every year more and more tools are unveiled and usable, and they're fulfilling the dream that was kind of set out many, many years ago, and it's, as these things do, they take a lot of time. So, okay, so that's the mission. What are the values here? I think it was important to talk about this because in the blockchain crypto world, sometimes we get lost in the money aspect of it. And so really, this is what drives what we work on, what Filecoin works on, what we're all working on. And it's essentially digital human rights. So I won't go through all of it, but secure data publishing, secure networking, secure storage, fault-tolerant systems. These are things that we have the modern technology to do, but the way that the traditional internet has been set up, we are not doing it like that. And so there's a lot of opportunities for all of us to help usher in this new era using these rights or these values as kind of the North Star. Okay, so talking about the values and the mission a little bit. Now, okay, let's get into like the two big important pieces. Each piece has all kinds of projects underneath, which I'm not going to get into. There won't be time for that. But IPFS is the sort of the initial place where Protocol Labs started. Who here is familiar with like BitTorrent? Cool. I won't ask if you've used it, but I just want to know if you're familiar with it. So if you know about BitTorrent, then you know a lot about IPFS already. It's essentially, it's a peer-to-peer network where you upload data and the data is shared across a variety of peers. And as a user, when I'm calling some data, requesting some data, that data will come from the closest peer to me. Obviously, there's a lot of nuance there and there's a lot of details there, but that's the general premise. And the really exciting thing about IPFS is this content addressing. So when data gets uploaded to the network, it's assigned a unique identifier based on the binary of the file. So what that means is when a new file gets when that file gets edited and the binary changes, a new ID is generated. So now all of a sudden we have verifiable data that we can trust. And we know if we're looking for this specific CID, this specific identifier, and we're calling it from the network, we know that what we get back is going to be the data we're looking for. And so this is really a fundamental shift because the way that the current internet works, that's not the case. And so it's a big topic to talk about how the current internet works, but there's this awesome graphic that someone from the ecosystem created. And essentially, it's talking about breaking free from the client-server model, right? So the way the current internet works, we contact a server, and that server sends us back some more data, right? Whether it's a file or anything, right? And so that is a central point of failure that is basically built on very old technology. And so what IPFS is trying to do is basically solve a lot of these problems. And so so basically the story here is when a service goes down, or when data is taken down, or if a service is compromised, all of a sudden as end users, we have no control, and our lives and maybe even our businesses are affected because we don't have control over that system. For example, we build with a lot of microservices, a lot of APIs, right? So we rely on a lot of cloud services. If that stuff goes down, we don't have much, there's not much we can do. And so the whole idea here is to build a verifiable content-addressed web that developers can rely on to be there when they need it. Any questions on that? I could probably explain it better, but I don't know if anyone. Yeah.
This would probably go to the details, but I was thinking of how do you actually host the files, and how do you make sure that it's available enough when have a spike and my website's popular all of a sudden.
Yeah, that's a great question. Yeah. So the way that the network was initially created is people run nodes on their laptops, people run nodes on servers, and those nodes get distributed across the world, right? The problem is what you just said. I have a company and I have 100,000 requests going in one day or 1 week, whatever. How do I know that those nodes are going to be servicing that request? So there's a bunch of companies that have popped up in the last probably 3 or 4 years, and they do this exact service. And so they're called pinning services. We're actually sort of trending in that direction. But essentially, there's companies that help you onboard data to the network, and then they provide the hosting guarantee on that, as part of that deal. So you can basically use them as kind of the service provider to basically save data to the network, and then as an application developer, you can use their APIs to call that data and to do different things.
And do you have to trust them like you formerly had to trust
Well,
AWS?
the awesome thing is you're addressing with a content identifier. So if you're asking the question, you know what data they're gonna send back, because you're asking with something that can't be changed. So
you don't have to trust them. That's the point. Because they're hosting this data in these nodes, and as long as it has that content identifier, you can be certain that they're giving you the data that you're calling.
What about paying for the storage though? If you rely on them to do that and then they don't do that?
So that's all inherent of building any system on the internet. IPFS has given us a new protocol in which you can transport data. They haven't replaced modern, you can't replace physics in which somebody needs to be hosting something. So you still have to host it somewhere. Just now you can actually verify that the data you're hosting and you're retrieving is like the data you want. And Filecoin is the commoditization of that storage. And so like now we've gotten like commoditized data. If you have storage, you can host it to our network and people can store it with you. Like people will store on your server and you're given money. And they do it directly now. So that kind of like takes care of like a lot or some of the hosting, you know. And
Yeah.
So
Yeah.
the main benefit is security, that I know what file I'm getting.
Yes.
Yes.
Yeah, you can validate.
Yeah, but also
with
like,
the hash that it's the actual file that you're requesting.
yeah.
And then Filecoin is interesting because you don't have to necessarily trust the provider that you're storing it with. You can just trust basically the code that runs the network, the different mechanisms on the network. They have to submit verifiable proofs. I think it's like every hour, and then every 24 hours. If any of those proofs weren't submitted correctly, they'll another 24 hours later, if they still haven't submitted those proofs, they'll get docked money. But the money only comes out of your account once they've proven that they're still storing the file that they've proven is your file, right? So, yeah, it just adds layers of trust,
And if they don't
verifiability.
pay that, you see that they don't, can you make the payment before it essentially that data vanishes from the network because nobody's paid it,
Yeah.
there's no incentive to store it, or does the storage fee have to come from the originating source?
Oh, I can add a little bit to that.
Sure.
Sorry if this is way
No,
too.
no,
No. Like I said, interrupt away.
These are great questions.
On Filecoin, you see it as when you're working with storage providers where you're like storing the data, it's not just going to one place. It's going to 10 places, right? You want that 99.99999 like resiliency on your network all the time, right? So how many nines you want depends on how many copies are being distributed over the network. And that's kind of up to the client, and you can store it as many times as you want because the storage providers that are storing it are incentivized to store it, right? But the other side, right, what Dante just mentioned is that if they're not doing what they should be doing, right, they get slashed or penalized based on, you know, the amount of storage that they're not hosting anymore. So it's two ways, like it makes the data immutable, it makes it verifiable, it's always online, and the data itself, the people that are storing it are incentivized to keep it online because else it's costing them money. Like, if you look at all these benefits, no cloud provider on the planet right now does it that way, right? AWS is not gonna be penalized because they're not, you know, storing your data anymore, right? So it's a way different economic model to make sure that the data is always there. And then based on the CID that IPFS is based on, you're 100% sure that the data you're accessing is that data. So even if it changes, it's a new CID, so it can never change, right?
Yeah.
Does that make sense?
You had a question?
No, that's just basically how I understood it. It's kind of like if you have each computer, well, the way I understood it, I don't know if I'm right or not, maybe correct me on this, but it's every computer can potentially be a node where you would end up, if you have free space in your hardware, you end up storing some of that files. And so there's no point of actual failure. So let's say it's I won't call you D because I don't have your full name.
Doubts, yes.
His computer goes down where you really can't access your information from his computer, but then you'd still have the information that's still active on this computer. So you'd still be able to pull up the exact same file you were asking for because.
No, I understand that, I
For
guess,
IPFS.
to use a specific example that might illustrate the point, Web3 social is hot right now. I can go create a lens profile, I can upload a video to the blockchain, to Polygon, and I can choose Filecoin as my storage, I can point it to IPFS, but then I'm kind of relying on that DApp to pay that storage for me, for the video that I own, that's my content, but I'm still trusting that that network is going to continue to make those payments, because if they stop, then there's no incentive for anybody to store anything, it goes away eventually. So I guess my question is, if I, either as the DApp provider relying on one of these middleware people, or as the end consumer relying on the social DApp to pay that storage, I can verify if it's been done or not, but if it hasn't been done, how do I then make that payment from it? Does it matter who makes the payment? Does
Oh,
that
I
make
see what
sense? So
you're
that,
saying,
not the redundancy of it, I get that, but.
Definitely, yeah,
Yeah.
you can
So
be agnostic.
you're saying like you wanna pull it back at some point, right?
Or just like, it's my video, it's my content, I own it, it's pointed to me, but I relied on a protocol or a DApp to upload it to Filecoin
Right.
and make that payment for
Yeah,
storage.
so that's
And maybe
the-
they go out of business, and
Yeah.
Yeah, so
then nobody makes those
that's the
payments
beauty,
anymore.
Yeah, that's the
Yeah.
beauty with the CID is always the same, so you can download your own stuff back again and then put it somewhere else, wherever you choose.
Or you can use multiple providers too,
Yeah.
to where you can address with
That-
5 different providers like we do.
Yes.
And if one of the whole, like we address with web3.storage and with lighthouse.storage. So if web3.storage goes down, we're calling the CID, our users are calling the CID. It doesn't matter who it's hosted by.
Yeah.
So that's
you're
called,
you're not wrong though, like.
yeah, that's like
Yeah,
something,
Third
that's,
parties can go down.
yeah, that's any
Right.
company. You work with, you can't like, yeah, that's modern companies, right?
Yeah.
So,
Yeah, I'm just, what's the, anti-fragile solution to that,
Yeah, so my company is actually, we created a service that spins up a Kubernetes cluster for you. So you own the cluster, you can select your providers, and it'll run IPFS nodes on there. So when you upload files to it, it's your own private IPFS network that if you wanted them pushed to public IPFS or whatever, you can. It also backs up data to Filecoin automatically, and you can add as many nodes to that network as you want.
so yeah,
You know?
the value in that is that you can ask multiple people. And you
Yeah.
can't do that with Amazon right now. If I have an app,
Right.
you're addressing to an S3 bucket, you can't address to multiple S3 buckets unless you wanna waste resources.
Right.
Whereas now you can just address to, like whoever is called racing gateways. So you list like 4 different gateways, whoever returns it the fastest is the one, great, cool.
Yeah.
And then you log that and then keep track of who's the best gateway is.
Yeah, so something we've been kind of loosely talking about is like the serverless bazaar, where you basically, like to Logan's point, you can, our application open links addresses to multiple different providers, but we're gonna get back the same data every time.
Right.
And so that's kind of the really cool thing about it, is it really allows you to kind of be flexible and be resilient. Yeah.
What does the actual implementation of fetching data off Filecoin look like? Because I had an issue with IPFS where we were building a project, and one of the challenges that we faced is that we were hosting the code for our project on IPFS, but we, IPFS works like a tree, right? You have to recurse to the tree to find where the data is, unless you know that specific spot on the tree where it is. And so the data is decentralized, but the pinning has to still be centralized, right? So is it the same thing with Filecoin, to where I'm storing it on this network and it's still like I have to like recurse to the tree to get that data? Can I set this pinning somewhere in a decentralized way, or how does that process work?
So I'll give my answer and then actually, Angela, you just go ahead. You got it.
Storing it on Filecoin, I think that's the easiest way to look at it. Usually it's like a one-on-one relationship with the storage provider or the mini cloud or whatever you wanna call it. Stored once, right? But through programs or through your initiative, you store it on multiple locations, so that's the way it's getting stored as of today. To your point, if you wanna access a specific set of data directly, it will go through the indexers that are running on the network, so you can, contact the indexers on the network and then get your data directly that way.
So I contact the index or the network using
That's the same, it's a CID.
CID, okay. And that performance, like what does that like look like in real time usage? Like let's say I'm posting code for a web page, just arbitrarily.
You want to do real-time data access on Filecoin. That's what you're asking.
Yeah, is that reasonable for real time access or not?
Right now, you need IPFS for that. That's the hot warm solution in front of Filecoin. See Filecoin as an archival solution of data, of massive data. That's why the scale of the network is so big, but it's not hot data.
I see, so it's better for things where it does not need to be accessed often, but needs to be accessed occasionally.
Well,
so
it's-
like a backup.
It just depends on what system you're, like, if your system requires hot data, then you're gonna need to use the protocol that fits that, right? So Filecoin isn't necessarily like your option. Like, the hosting still is the same as it conventionally would be. Like, if you have 1,000 users all around the world hitting a server, it's like you're gonna have problems there. You're gonna need to have a load balance solution for that. Like, you're still gonna need to have that same solution using IPFS if if you have a big app that has a lot of users, right? Does that make sense?
That makes sense, okay.
Yeah. So like, if it's something light, like a little tiny web page, then IPFS is great, because it's like, you know, it's like in terms of optimize, you only need a few servers around the world to run that. Whereas if you're running something heavy like a video storage platform and you're running it on IPFS, the infrastructure is the same as it would be without IPFS, kind of, right? You probably need a lot more infrastructure for IPFS, right?
Yeah, a little bit more.
Right? Just because you got hashing, if you're running Filecoin, then you have to prove everything, then it's really a lot. So IPFS is a way to like protect the data that we're running, and it's like, it's a whole new paradigm shift, because once you figure out how to do it, it's like, okay, everything changes. And so, but you still have to figure out hosting and load balancing and everything.
Yeah, totally. And also, yeah, I've got a Filecoin slide coming up next. We're kind of talking about IPFS kind of in a limited context here, so I'm glad we got to the Filecoin part already, before. But because really this, like Logan said, you can use IPFS separately. You can do some stuff on Filecoin, which does use IPFS. But really, like the stack is what's like very, 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 very exciting. Is there's so many different projects under the Protocol Labs umbrella that are building off of the verifiable data, like retrieval networks. You mentioned indexing. There's the storage, and so I'll just skip through to my next slide. Filecoin is essentially commoditizing this verifiable storage, and so that's what you think of it as like a crypto-powered decentralized storage network. I think we pretty much talked a lot about what I was planning on saying anyway, but essentially the mission for Filecoin is to protect and store humanity's most important information, and that was really like the initial use case and like the initial user base, and then from there it's grown like crazy to tons and tons of different applications and tons of different like commercial applications, and they also, so like I mentioned, they're building all kinds of projects on top to make the archival storage more useful, and to so for example on the far left they just launched the Filecoin virtual machine, so now it's EVM compatible, so you can launch smart contracts directly on Filecoin. And then I mentioned retrieval. There's the Filecoin Saturn network, which is a global incentivized retrieval network for Filecoin data. So yeah, when you take each piece out of context, it makes a little bit less sense than when you take them all together as the full stack. And the full stack is really what, you can use the different pieces of course, but the full stack is also what makes it really powerful.
Is Filecoin analogous to storage or SIA? I mean, obviously there's different features, and I'm sure you'd say Filecoin's the best of the three, but is the same spot on this total stack?
They have like 95%, 96% market share, I know for sure. And in terms of scale, in just like 2 years, Filecoin grew to about 1% of all global cloud capacity. So that's from my perspective. I don't know, Angelo, if you want to add to that.
Yeah, it's the massive scale that Filecoin can handle compared to the competitors, or whatever you want to call it. That's what makes it strong and makes it a very good archival tier at that point. And we've been throwing petabytes and petabytes of storage against it, and we're just going at it. We're at, what is it, 13 or 14 exabyte right now?
I think 15.96. I just got that number. Yeah.
And it keeps climbing and climbing.
Yeah.
It was close to 19, I think, like last month.
Oh really? Yeah. Yeah. This was just from this last NRES meeting.
And how distributed is that? Is that one of the?
So if you look at I know those charts too, by chance, see them a lot. The green part, I think that's the Fill Plus data, which is replicated 5 times over the network. And you see that that's growing the most because we're focusing on actual data, while the blue part is more of the committed capacity part, which is telling, look, this is the kind of capacity that we have that can be filled, and it's kind of for the security of the network. So you see that they're like the blue one is staying the same, which is very important, and the green one is growing, which is the actual data being stored at this point.
Yeah, and also just to add, Filecoin Plus is like the sort of like, and correct me if I'm wrong, but it's sort of like the commercial enterprise version of Filecoin. So for companies who want to feel more comfortable about using this new storage platform, that's 98% cheaper than AWS S3. Then they would use Filecoin Plus, and because there's deals with those storage providers that I believe they have like SLAs and everything in place. Or
I think I'll take that apart a little bit. So Filecoin Plus is the extra incentive layer, let's put it that way, to make it very affordable for anybody to store data on Filecoin. What Filecoin Plus actually does is everything is based on proof of work, let's put it that way, right? So there is a certain amount of power that you have in a network based on the amount of storage that you're proving to the network. Well, if you're storing actual data, Filecoin Plus will 10x your view on the network. That means that if you're storing 100 terabytes, that will look like 1 petabyte on chain. So you're earning block rewards over that 1 petabyte instead of over the 100 terabytes, which makes it very interesting for the storage provider to do because you're earning 10x the block rewards at that point, which makes it very interesting for clients to go through the verifying process to store that actual data because they don't need to pay anything at this point because of that.
Is it Filecoin is proof of work?
Well, proof of storage,
Yeah.
it's like proof of work is what most people know, but it's proof of storage, that's what they call it. But the proving part is still you're putting in the work with the GPUs and the proving all the
So what is
sealing.
the proof of system look like?
It's very
So, yeah,
resource intensive.
I don't know if you're getting into that in a little
No,
bit.
no, no.
Okay, that's gonna take a little bit longer than 2 minutes, but.
Sealing data?
Yeah, so,
Supercomputers, basically.
what I can do once we're finished doing the presentation, I can pull up a chart on the entire sealing pipeline from a storage provider perspective, and I can explain that to you. How that works, you're right on.
What the storage proof? No, so I guess the question I'm getting at is you kind of said it's proof of work that you're showing that you store the files, but like I can hash a file, I can do a checksum or something like that, but what I'm trying to get at is kind of like it's proof of work, not really, like is it proof of stake, am I making an attestation of something here?
Yeah,
Or
so-
what
We call
is
it
that
proof of
actual-
storage because it's actually both when you look at it from a storage provider perspective. Because what's happening is that when you're as a client storing data at a storage provider, that storage provider ingests that data, it was gonna prep that data to store it on Filecoin, right? It creates proof for it, makes it verifiable, makes it that the blockchain can verify it every day, every 24 hours. And that data goes through a sealing pipeline that takes a couple of hours before it's ready. That's the work, right? Then storing it on Filecoin as that storage provider, he needs to put up collateral, which is the staking part. And that collateral is kind of saying, I'm putting up this kind of money to make sure that your data is being kept safe. Does that make sense?
So it's like proof of stake, but you're attesting that it's correct, and then who checks that you didn't modify the file?
That's the
The network.
chain, and also based on IPFS CID, that CID never changes, so it makes it immutable. If you change anything on the data's not valid anymore.
I see.
Yeah,
Yeah.
it's
Yeah,
proof
the
of,
CID changes, right?
proof of storage because it's a storage network.
Yeah, and also the encryption, I think the encryption scheme to prep it for sealing is like if you tried to run that on your computer, could take like a year.
It will
or
burn
something.
out on your end,
Yeah, it
you
wouldn't,
need enterprise
like,
grade
Yeah,
stuff.
you need basically a supercomputer to do the encryption, yeah, just for sealing, and then every 24 hours, there's other proofs that are a little bit less intensive than the initial one, that, again, it's just like proof of work on Bitcoin. You got all these people doing these puzzles, solving these puzzles
Alright,
all
but
the time.
what are those proofs? Like, I'm not just solving arbitrary puzzles here. am
They're
I?
proofs. Well, yeah, the proofs are basically,
They're hashes of data. You need to go
Exactly.
check and make sure that this data is authentic. You need to go
Yes.
actually and check and look at the bits. You know, it's,
look at the bits.
My understanding is that it's a zero knowledge proof.
Yeah, it's,
Yeah.
yeah,
So-
that's the actual words
Right.
of it.
Yeah.
But
Yeah.
what it does is, look, every sector is 32 gig or 64 gig on a storage provider. Most people do 32 gig because that's the easiest to manage on the entire infrastructure. If you have petabytes of storage on your system sitting there, that means thousands and thousands of 32 gig sectors, right? During that process of that check every day, what your system does is it will take random bits of every 32 gig sector, computes a hash over it, then goes to the next sector and does that all over all the 1,000 sectors, and then all together it will create a proof of all those different hashes, push that to the blockchain, and the blockchain will check if you, within that half-hour window, have proven that your data is still intact and still unchanged, and then everything just is fine. If that doesn't happen within that half hour, you get penalized.
So in the half hour, you're basically checking random bits, you get the hash too, and then you're checking that it doesn't violate given the history of the chain.
yes, there cannot be any violation on the data.
Yeah.
Any violation of data.
Yeah, so other storage providers are doing those proofs too, and
Exactly.
checking against each other to make sure that they match.
Yeah.
And if you're the first one, I believe, if you're the first one to submit that proof, that the confirmation, basically, you get that block reward as a storage provider. So storage providers get paid for storing data, and you also get paid for validating blocks, just like the
Yeah, you're
Does that
storing
mean
about.
to, because of the computing power required for that encryption, does that mean that it's very centralized, only like big mining farms, you know, Bitcoin that are, you know, control 50% of the hash rate? There's
No, I feel like everybody has these freaking massive supercomputers. They're not.
I
It's
can tell you around more on the spec if you want to. Like, there is around almost 4,000 storage providers right now, I think, in the network. All 4,000 are running at least some AMD APIX with enterprise grade NVMe with like high-end, multiple thousands of cores CUDA. And the part on the ceiling pipeline is very heavy on memory and CPU. And there-
GPU.
No, CPU, the first part, and then there is the proving part and the calculation part in the end, which is GPU intensive. And then the proofing part that happens every half hour is very GPU intensive and disk intensive. So you need a decent setup, right? I can show you my setup that I'm running in Brussels if you want to.
There's like 4,000 or more.
There's like 4,000 people, and that's how we distribute everything, right? So
Alright, strict question, so then, like with Bitcoin mining, electricity costs, etc., you can kind of arrive at a point where miners are gonna be losing money if the price, market price isn't a certain amount. Given that Filecoin, you know, it's gone from $300 down to, you know, $5.
of course.
And, you know, it's what, 400 million tokens, gonna go up to 2 billion. You know, let's say there's another bear market, you know, well, maybe we're getting out of one, maybe not. Is there a price where these expensive setups need to maintain so that the rewards they realistically earn are realistically worth keeping those machines on?
I do know that number because I did the whole ROI calculator
Yeah.
for a lot of them. It depends on the scale, right? That's one thing,
Sure.
right? Look at Amazon, they're not profitable because they're small, right? Like, because they're big. It's the same thing for a storage provider. Depending on how much you're providing to the network, of course, impacts your revenue model. So to ballpark it a little bit, I think the price for, if you're at a certain scale, let's say 50 petabyte or higher, you'll be like at $3 that it should be at, right? That's ideal based on, you know, block rewards and that you get in and everything. Now, a lot of conversations happening right now that, you know, because of the incentive model, like you just said, right, is that people are looking into charging for their storage, because it's a normal evolution in the network, right? Now, most clients are storing data to prove utility, it's incentivized by block rewards, but if, like you're saying, that cannot go on forever. So we'll have a mix of both at a certain point, and then further along, you will have just, that mix will still be valid or still available, but that will just change. It will be less block rewards, more charge, more storage, but that's gonna be over the next years, in my opinion. But there is a model for it to make sure that
So
it's.
ballpark about $3 if Filecoin just below
That's
that.
for 50 petabytes though, that's a whole
Yeah.
data center almost.
Yeah.
That's a lot.
And so for a smaller mom and pop kind of
So I
provider,
run my
double
setup
that?
pretty small, I guess it's like 2 petabyte or something like that. I don't know if that's small, but it's still a lot of storage, I can assure you that. It's even lower, you can even go lower depending on how scrappy you are, so
No,
depending on
yeah.
how you structure it. But if you go buy everything brand new through a leasing contract, whatever, with Dell, HP or whatever, Supermicro, whatever you wanna do, depending on scale, yeah, that number looks different for you. I can show you the ROI calculator in a little bit. You can just go to Filecoin.eu, you can play around with it, how that looks for you. Also depending on that incentive model, on Phil Plus, if you wanna figure that out.
If they're gonna move to a model where you charge for storage, aren't you then worried about the potential of, you wouldn't wanna run up against like Glacier, from AWS or similar
Oh.
services.
That's what we're 100%.
Exactly. You wanna run against them. Yeah.
No, I mean, you wanna be cheaper than them if it's the.
Well, actually, I always disagree with my colleagues
Okay.
because they say the same things. I always say we need to be at the same price point because we're offering a lot more.
Right.
We're offering content addressable, immutable, replicated storage for the same price that Glacier does in one location.
It's more redundant.
So you get a lot more for your buck if you're.
And just a question, I work in the finance industry, so I deal with a lot of like, okay, the traditional finance industry.
Yeah.
So, how do you make sure that, all right, you're storing it in 5 separate nodes, how do you make sure those nodes are distributed broadly and not all, say, within 50
Okay,
mile
so
radius?
we have an internal validation bot that checks that. So if you're running with the incentive model, we force that the replicas to be stored outside of the country once at least, so that's definitely different data center setup. Definitely twice out of any city, so those rules are there for a reason. The validation bot will check that. And what it makes it that way is that you're always talking to data centers that have 100% unique setup, which is also the attack surfaces off the scale, right? If you want to hack 5 data centers distributed over countries which have a completely different setup, well, I mean, good luck for that hacker to bring down all 5 replicas, or even I see people do 10 replicas even, so that makes it very
Yeah,
robust.
there's usually an off-chain backup
Yeah.
also.
That, yeah, still that.
But are all these data centers running the same processors? Are they all running AMDs?
No, they're all running different.
Or are they running
Yeah.
ARMs
Depends.
or RISC-V?
Who knows? Who cares?
It's all running
The-
Oh, I guess it's all, we know what it is.
I know what it
It's
is.
x86 for sure.
So for certain process, you needed certain specific types of CPUs or GPUs, right? Best is AMD to run the ceiling pipeline, but on the data access part, for instance, I run it on VMware, which is way different than, somebody can run it in Docker, or somebody can run it in bare metal on AMD or Intel. For instance, I have a Fortinet firewall in front of it with IPS and DDoS protection, and other people have a Palo Alto, some people do advanced IP tables, so you have a mix of so many different things that, look, I come from a security background from Fortinet. I can assure you it's already hard enough to get through one of those. So if you want to penetrate 10 of them or 5 even, it's going to be tough. I mean, specifically, they're all different. And even looking at the software stack, because that's probably your next question, is all the same software, which is also not the case. A lot of people, we have different, we have Lotus implementation, we have a Venus implementation, we have a Rust implementation, so it's also different software accessing it.
Well, yeah, I was just gonna say hardware is a bit easier to come at it from, because like AMD could just insert another chiplet in there, all their chips, and it could wait until it sees some message come across the bus from the internet and I don't know, catch fire. That's not a very, that's more of like a DOS attack.
Yeah,
where it just catches fire on the chip, but or it could just start manipulating data.
They do that all the time. There's those weird things in processor all the time. Intel be turning weird shit on all the time. We'd be mad.
I mean,
It's one thing to answer what the question about like ceiling and how expensive. I know like last year we were doing the numbers of like, okay, how much does it take to get like a big, service or a small service going on Filecoin? And it was like 15, maybe, it was 10, 15 grand if you were even buying used stuff. And this year, AMD has come out with their new AM5 stuff, and it's like, I'm sure that price, I haven't done the numbers, but I'm sure it's a lot less than it was.
proofs are being optimized right now, and you can run your ceiling pipeline on less hardware. It's better now. You can almost go to like a whole storage provider in a box, almost putting it together, but still look at this cost what it is cost, right? No matter where you go, AWS maybe gets a better price from WD or from Seagate or whatever, but the disk is still pricey on that, so you still need to store it. Filecoin has that incentive layer to offset that cost, so it does help. I mean, that makes it interesting for the client to store it on that part.
I had another. Can you delete from Filecoin? with it, cause the CID, it's a hack.
Why would you ask that?
Dreaded
Sorry.
Well, I wanna say, hey, guys, you don't need to store this anymore, stop
Okay.
working on it.
I'm from Belgium, so I'm really focused on GDPR, so this is the exact question that I
That's
asked before
right to
I
be
started
forgotten,
at Protocol
right?
Lab.
That's harder deleting.
Yes,
I guess
so-
I was saying
We have-
relinquishing.
There's a lot of things to make sure something is stored. Now we need to figure out of something to make sure that, okay, you're not storing that anymore.
What you can, what you can do is first you can deny access to it, which will, for a lot of those compliancy methods is enough, right? But you can also terminate data on Filecoin. That's a new feature, like it's not a new feature, it's been around for a while, but you can terminate and delete the entire sector. You can obfuscate access, and you also have the part where you can just say, well, I won't allow you access anymore, and I'll just wait till the deal duration is over, because deal durations are typically 540 days, and then the data automatically gets deleted based on your policy.
Okay.
That's probably the cheapest way to do it, right?
Yeah, that's the cheapest way to do
Yeah.
it, just
Yeah.
wait for the.
Like if you, like when we were just talking about the incentive layer, is that if you terminate it, you're saying to the network, hey, I'm terminating this data because I feel like I wanna terminate it, and the blockchain will say, well, that's fine, but you'll have to pay a fee, and that comes out of the storage protocol.
There's a system that does that.
So when you're saving something from like Polygon, I'm assuming there's some kind of bridge for the data?
I think there's a bridge for it.
Okay,
I think
for
there-
most
I
like
don't, I'm not, I've heard.
EVM type,
Oh, yeah,
it's
yeah.
EVM
You can use, like-
compatible, right?
You can use Web3 origin or something.
Oh, yeah.
Alright,
for
so
sure,
then
yeah, yeah.
what about, you know, a big problem now, you talked earlier about, you know, like the next 80 years, we're walking into a surveillance dragnet, so the whole lunar punk versus solar punk, and especially, you know, most EVM addresses, your entire history is public, your identity is public. If you have associated it with, let's say, social media account where you've attached credentials, or you've doxed yourself, and then you're uploading videos, content, and then there's this bridge over to Filecoin. Can the Filecoin data provider or data storage providers see, is there a link to that like ETH address identity, and then could that be used to censor, let's say you don't agree with the politics of the person who's storing their, you know, blog content?
Oh, yeah.
Can you then, as a provider, is there a traceability not only for you as a storage provider, but really ultimately governments, regulatory agencies who would then also use that pass-through method to just kind of figure out everything? I know the data is encrypted once it's kind of at rest, but can you see the identity of the incoming source of that? And
Yeah, so like you always see the source client, which is the wallet address.
Right.
And if it's, there is a wallet converter for Ethereum wallets, so you could, you know, I guess you can figure that out. But to give you an idea, like we're focusing on like, for instance, research data, right? And the researchers, what they want is they want to store data, and from the second data leaves their infrastructure or notebook, they want to know what's happening with it, because it's very important that it never changes. So what they do is, oh, we'll put it on IPFS, right? The CID makes it immutable, you always know that it's the right data, then it goes into Filecoin. Same thing, new CID, blockchain checks it, and then, but you need to figure that out yourself. Nobody's gonna tell you the entire trace of what that is, so people are developing software right now to visualize that really quickly for you, to figure that out for you, so you as a client don't need to go through, traverse the entire, you know, IPFS world and the blockchain and all that for you. And I can imagine that if it's coming from a network outside of Filecoin, people will develop that as well. So does that make sense?
so there is a, like, I don't know if you've seen like the past couple of weeks, there's been these hearings with Matt Taibbi and some other people, the Twitter files, where it's been revealed that there's been coordination between government and private industry to basically flag, censor, and deplatform certain individuals sharing certain content, whether you agree or disagree with the content's relevant. Point is, it's a mechanism by which a governing authority can see the origin of this data and censor or repress it, or by just not making anything illegal, but they just lean on the private company. They then lean on the individual storage providers and saying, we've decided that's
No, you
hateful,
can't.
misinformation, hate speech, whatever bullshit.
No, the thing is,
And-
there's a good example with the war in Ukraine, for instance.
Yeah,
I know
okay.
the Filecoin network is storing all the videos and text around it.
Right.
Once it's stored on Filecoin or on IPFS, the CID makes sure that it never changes, so you know it's there, right? And by accessing it, you become an IPFS node at that point too, because you cache it. So anybody who reads it, all of a sudden, if 1,000 people read it, that file exists 1,000 times, which is unchangeable because of the CID. And then when somebody wants to delete it, that's impossible. Even accessing it would just create a copy at that point. But what I'm getting at is that in that case, if somebody would tell, a platform to delete it, it's still okay. Let's say the platform points it at a certain, it can be a file, it's a CID at that point. So even if the entire company would go away, or they will like force them not to reveal that content anymore, that CID is still available, and you personally can still access it and knowing it's the original data.
That's a great example. So, especially here in the West, Russia is seen as the ultimate bad guy, and if you question that, you're a traitor forever and ever, and you need to die. And so there are some sources from within Russia that might have some criticism of what's going on from a socially unacceptable point of view, and they might choose to upload some of this video or whatever their content. And like we've seen even in the past year, like decentralized exchanges like Matcha, which is powered by OX, just cut off any incoming requests from Russia. Like, I don't know how we're decentralized if we're gonna say, if you're a human on this side of this arbitrary line, then you can't exist or whatever.
It's more for legal and compliance reasons.
Well, I mean, that's the example of, soft persuasion by governments that, lean on and get the desired censorous effect without actually making a law. And so can that apply
you're really
to?
blocking access to the front end, right?
Right, so can I,
smart
if,
contracts are always on chain.
but if I'm in Russia and I'm uploading videos, hey, this is in my backyard, can a storage provider say, hey, we don't wanna host that propaganda?
Definitely, like a storage, a storage provider, they have to abide by laws, right? So like, the awesome thing about IPFS is like, you can go intermediaries, you can go to people who don't follow laws, like that's the great thing, but like, they still are service provider. If the government, so like, we have this problem if you're like hosting content on IPFS. Nobody can it's not a good idea to go start saving illegal prohibited content on IPFS because it's still prohibited content. So if you try to send that to a service provider, the service provider is gonna get a notice from the government saying, hey, you've got content here, you need to stop this. And so so it's you follow under the same laws. It's just the circumstances are a whole lot better on IPFS than they would be in a centralized system.
Well, and that's the thing, if we could trust governments, then we wouldn't need this blockchain stuff.
Yeah, well,
There's also mixed nets are getting better, just as the ways to analyze the networks are getting better, mixed nets are also getting better. Ways to obfuscate
The source
where
of the
it came
data
from.
so that, and it's encrypted once it hits it, so if
mixed
you don't know
nets
the
are-
source location,
They're
then.
trying to make all traffic look like the same
Yeah, right.
traffic, right? So
And then obviously
it's
if you're
pretty
still uploading illegal stuff, then there are ways to get you from the other side, but it just wouldn't be.
Yeah, and my understanding is with the IPFS public network, there's hundreds of thousands of nodes, if not close to 1 million nodes. And so if you're in Russia, is that
who
close?
knows?
Who knows? It's hard to know,
Yeah.
right? But the point is, if you're in Russia and you upload something, or you're trying to retrieve something, you
Right.
can do that because you're running a node on your computer, and you just talk to those other nodes.
I
And
guess
so,
it's the storage providers that may be the ones that say, we choose to not host
Sure,
content
but
from
those-
this geographic
those
region.
IPFS nodes in that public network aren't always a Filecoin storage provider. It could just be you with
Yeah.
your computer.
IPFS and Filecoin are two different networks.
Right,
Yeah.
sure.
So you can. So another great example, actually, the government of Iran blocked Wikipedia
Great
for the
example.
whole country.
Right.
And so IPFS has had Wikipedia. I threw this in here because I feel like this is super important. Safeguarding humanity's most important data. So they have all the Wikipedia saved on the IPFS public network. And so when Iran shut it off, all the citizens could still access it through IPFS. And so that's a really, really powerful mechanism. But they had to be running their own nodes, right, locally.
Right.
They weren't contacting they didn't have their own Filecoin storage provider.
There's some browsers nowadays that support IPFS, like the
Right.
Yeah,
ones.
yeah, that's I had that here. Yeah, there's 5 browsers with IPFS support. and 3 with native support.
So someone in Iran could go to Brave, if they could get Brave on their computer.
Yeah.
And then boom, just like a
And
Wikipedia
they
through
just like
IPFS.
just browsing the internet.
Can't you use a VPN to get bypass the
Yeah,
Iran
probably,
firewall?
but not everybody's that tech savvy to go
Yeah.
figure that out.
Well, no, I mean,
You have to be
VPNs,
paying for a VPN, so like there's a lot of people who are
there's some
immediate.
free ones. They collect your data, but
Yeah, exactly. That's the other
so
thing.
you can go download Brave with it.
Do you want a centralized party to obfuscate your communication? Do you want to be using IPFS?
Yeah.
Like that's your question.
I do wanna add something to that, because like, I think the video part is a good example. Try not to see it as a video file, but see it as a unique identifier. I think that's very important, because on IPFS, you're not going to the content, you're going to the identifier, and that identifier will give you the content, which is way different.
And if only somebody was gonna make a video player that was based on content IDs.
If anybody wants to work with video, come talk to this guy. He's gonna love to talk to you.
Hey, let me talk to you later.
Yeah.
Okay.
So it'll just be like, it doesn't matter where it comes from.
Cool.
Like, it'll just be like this CID.
Well, yeah, so that's what I had. My plan was to basically get everyone talking, so I succeeded.
Good job.
Slack group, Meetup group, if you guys didn't get it already, that QR code should work. So if you guys want to quickly swipe that. But that's it. Thanks.
Thank you.
Taking up the whole presentation.